Welcome all of you. So this session has been completed devoted to the Python sequence, right? So let's see what is Python sequence, and before that, let's see which IDE we are going to use and how you can also download that particular IDE. So we are going to use Jupyter Notebook, even though you can download the Python separately and then you can use Jupyter with that Python, or you can download the whole package for Python, that is Anaconda Python actually, which is coming for machine learning libraries as well, right? So you will see there are a lot of inbuilt libraries are available with this Anaconda distribution, right? And if you go click on here like download, or you can choose here whichever version you are looking for, 3.7 or 2.7. We are going to work with the Python 3, so you guys can download this particular version, right? It is little heavy version, right? So means compared to normal Python 3, if you download from its official website only Python 3, then you are going to find, so this is basically is the place from where you can directly download the Python, right? But this is coming with a lot of inbuilt packages, and which makes the life easy. So we are going to use this Jupyter Notebook. So I'm going to start Jupyter Notebook for writing my code. So it is starting the Jupyter Notebook server for the Anaconda server. It is starting for Jupyter Notebook, and now it has started. And we are going to create a new Python 3 file in which we are going to do all the work. Okay, so Python sequences is one of the very important concepts in Python, which make a lot of things easier for a programmer, right? So if you have worked with other programming languages and if you're going to work with Python, then you are going to find that life is going to be far easier compared to working with other programming language. And one of the biggest reason is the Python sequence. It is going to provide a lot of such functionalities which is very useful and for lots of programming purpose. So let's start and let's see what we are going to work. What are sequences and what are the different types of sequences we have actually, which is provided by Python, and what are the operations which we can do on sequences. And later on we will see different types of sequences we have, like lists, tuples, strings, sets, dictionaries. Okay, so let's see what are sequences. So till now, maybe if you have worked with any programming language, right? So what you might have seen, so with the time actually, why I was not preferring this thing, because with the time I would be coming here, right? So you might be storing, if you have worked with other programming languages like normal variables, right? And here basically in the normal variable, you are storing one value, right? And it may be anything, right? Maybe some string might be there, right? And here, yeah, definitely if you are new to this programming language particularly, you might become surprised that here you doesn't need to define the data type actually, right? And this is wonderful thing about Python as well. You need not to worry about it, right? And here, so what I'm saying is I can allocate one value to a one variable, right? But many times what happens, I want such a container or such a variable, right, in which I can store multiple items, right? And that is what sequences are going to do. If we talk about like arrays, right? So we have, you guys might have studied about the arrays, and normally arrays you can see it stores homogeneous item, right? But sequences in Python, you are going to see it contains all kind of items, right? Heterogeneous items it contains. You can have one number, one string, randomly anything it can be. Okay, right? And for this we have one built-in functions available to us, right? And what does this built-in function do actually? That is len, actually len. It will tell how many elements do we have into our sequence, right? And how we are going to access these elements, like we will have only one variable name like a is equal to, and in this a we have all these elements, right? Different, let's say here I'm writing a particular car like BMW, let's say here I'm writing Scorpio, here I'm writing something else, and here something else, right? So four cars we have here, let's say into our this particular sequence, right? And we are calling them a. Using their positions into the sequence, we can access them, right? we have different kind of sequences, ordered and unordered. So ordered can be accessed according to their positions, right? So in which position it is stored, right? And we are going to see this thing, and this is what we call it as indexing or slicing. Okay, so let's see what are the different operations we can do. So one thing is very clear here to all of you guys, that we can store multiple items in single variable, right? I do not need to have different name for each of these variables, right? Okay, so let's go to next slide. So let's see what are the different operations we can do on sequences. So there are multiple operations we can do. So very few of those operations which we can do on sequences is like concatenation is one such operation in which we can concatenate together to make a new sequence, right? So it might have half element I have into one particular sequence A, and then half I have into other particular sequence, let's say B, and I can put them, I can merge them together so that the new one would be like half of this would be there as well as half of this would be there. So this whole would be combination of these two sequences, and we will say them concatenation because one after another would be available here. Okay, another is repetitions, right? So repetitions means sometime what we want is repeat the things, right? So repetition means I might want only there is one sequence. So there is one sequence. So here we can see basically like, okay, so we were discussing about the repetitions actually, right? So in the repetitions, what happened, that there is a one particular sequence, right? So I'm saying that this is the sequence we have, and now I want to create a new sequence, let's say B, in which this sequence should be repeated 5 times, right? So let's say if I have written 1 2 3 into this sequence, then what should happen in the B? 1 2 3 1 2 3 should come 5 times if I want to repeat it, right? So this way 5 times, and it will be creating this sequence. This is what we call as a repetition. Then we have a member testing operation. Member testing is going to be whether a particular sequence is available or not into my sequence, right? So whether a particular element, let's say if my sequence is having these car, let's say BMW, let's say Scorpio, let's say this is Maruti, right? And let's say this is I-10. Okay, so let's say these were our sequences. So I might be interested to finding whether BMW is available in these sequences or not, right? Or maybe Audi is available into this sequence or not, right? So basically it is, you can think like searching, right? So whether a particular element is existing or not, this is what we call as a member testing. Then slicing. So opposite of concatenation is a slicing, right? So what I might be interested, so in the concatenation we were adding two sequences, right? And slicing, what we do is we basically take the subsequence, right? So like there we have 4 cars, I might want to have new sequence which is a subsequence of it, we can say, and let's say it has only 2 cars, one is BMW and another is Maruti, let's say, right? So this is what we call as a slicing. So we will see all these topics in detail. Then we have the indexing. Indexing is what basically their positions actually, that this is at the 0th position, the first element always at the 0 position. So we start the positions here with the 0, and next one would be having 1 position, next one would be at the position 2, next one would be at the position 3. So we can access, let's say if I am interested only this particular item, I can tell that within this particular sequence I am interested into this item which is at the position 2, and doing this thing we call as a indexing, right? So concatenation they are showing like they are concatenating, actually concatenation and repetition they are showing in the same slide here, because you can do anything actually, you can concatenate. Repetition will also be the concatenation of same thing, right? So you can think that A is having some value and you have another B which is nothing but the A only, right? In which you are storing also same values which are in A. So if you concatenate both into a C, let's say A plus B we are doing, so what it is going to have, A first 4 elements, the next 4 element also will be coming from A, right? This become concatenation, or we can say it is a repetition, right? Because the first 4 element I have repeated, right? So if I want to repeat it, I can directly write here C is equal to, let's say 2 time I want to repeat here, 2 time it is coming, so C is equal to n into 2. 3 times I want this to be repeated, I write here C is equal to 8 to 3. Right? Membership testing, whether a particular element is existing or not, right? So let's say this is our sequence of cars, right? And if we see nano car is there or not into this sequence, then we are not able to find it. So it's not a member, right? So member testing will tell us that this particular element is not the member of this sequence. Similarly, if we say if whether this car is existing or not, then we can say yes, it is existing actually, right? Even it is existing twice here. Then indexing, as I told you, we allocate some positions to them, right? Here you can see the element which is first element into my sequence get the 0th position. Next element get the first position. Next element get the second position, right? Or we can say index 0, index 1, index 2, index 3. Right? And if we have 8 element, then the last element would be at the index 7, right? So always last index would be 1 less than compared to the total number of elements we have into our sequences. So now slicing, right? So as I already told you in the slice, sometimes you are looking for the sub part of your sequence, right? So this is a sequence you have in which you are storing multiple elements, right? And out of this sequence you might be interested in subsequence of it. Which is the subsequence of it? If you take these three, maybe anything could be subsequence of it, right? Choices basically means you are selecting sub part of this list, right? And there are few rules that which you can select and which you cannot select, which we will see. So here you are telling that I am interested in the element which is starting at position 1 and going till position 4, right? So it always go one less than whatever you will write here. So this is having 0th position, this is having first position, this is having second position, this is having third position, this is having fourth position, right? So first position is this element you are getting, then this element you are getting, and then this element you are getting, right? And as I told you, whatever you will write here, it will go just one index less than it, right, for giving you elements. So if you write 4 index, then it will go till third index. Okay, so now we are going to see what are the different types of sequences we have in Python. So we have these different types of sequence. One is lists, another is tuples, next is strings and sets and dictionaries. And very basic of these things we will see in this module, right? In this webinar we will see basic of all of these things, strings, right, list and all. So let's go, and first of all let's see list. So list is one of the most versatile data type. So we will see why do we call it versatile as well, right? And how do we define a list? Basically we write the name of the list we want to define. Let's say here I want to define fruit list, and here then I tell which operations which elements I want to store it within the square brackets, right? So I write here square brackets, and within these square brackets you need to write what are the fruit names. So you can write like mango, comma, another fruit name, comma, another fruit name, right? So that is how you are defining your list, right? And these are the commas which are separating it, right? And why we are putting them into quotes? Because this is a string. Mango is a string, apple is a string, grapes is a string, right? Similarly you might have, let's say, number list, right? Let's say I'm calling it as a roll number list, right? In this case how I will define is equal to, in the square brackets I might write 1, 10, 12, 15, right? So this way I can define my this list. Okay, and now here you can see these are not defined into single quotes, right? These because are just number. If you can define them with the single quotes also, but it will become a string, right? So these are the, like, we have the different data types we have into our system. Okay, now there are different functions which are available, even though there are lots of functionality available, but let's see some of the important functions which are available. One of the thing is that append do what? Basically, let's say I have defined initially this list, and after defining this, suddenly in my mind came, let's say this is a list which is used by a shopping, let's say shopkeeper, right? A fruit shopkeeper, right? And initially he has these fruits in his shop: mango, apple, and grapes, right? And after few days he decided that he will also keep orange into his shop. So what he has to do, he need to add here orange as well, right? So redefine, rather than redefining this whole list, what he can do is he can write fruits dot append, right? So append function will do what, basically, that it will take the earlier list, which is this one, right? And whatever you want to append here, let's say I want to append orange here, then I write here orange, right? We are going to see all of these things as a code as well, right? So what it will do now, it will create a, it will add one more elements here in the end, and this element would be orange, right? And this would be our new updated list, right? So this is what append functions do. Okay, so just let me make sure one thing here. Okay, so next page would be for tuple, devoted to tuple. So let's discuss here itself about it. Then we have the insert function. So insert function is what? So append is also inserting an element, but where it is inserting? By default, it always inserts element at the end of the list, right? So if I'm saying orange, it is coming at the end, right? But sometime, let's say you might be interested that in this case, in the case of fruits, it is okay that I can have element anywhere. But in some cases, you might have application where their sequence matter, right? Which element is which position is going to matter. So when you are adding a new element, let's say you want to add it at this particular position here, right? After mango and before apple, then what you will use is insert function, right? So append is also doing inserting of element, but it is inserting at the end. But insert is doing what? It is inserting at the particular place wherever you want to insert an element, right? So if I write here like fruits dot insert this function, and here I give the index. So here list name is fruits, so we write fruits dot insert is our function which is attached to the list, and then we are telling here what is my position. So this is at the 0th position mango, and earlier apple was at the first position, but orange I want now at the first position, and apple I want it should go one right side, so it would become second position. Grapes will get third position. So here I will write at the first position I want to insert, and whatever element I want to insert. Let's say if I want to insert orange, then I will write here orange. Okay, so this way we will be inserting element here, right? Okay, and now this way it would be then mango, orange, apple, grapes. This list would become, right? Then another function is also there, which is extend. So what does this extend function do? It is like append, but there is a difference. Append, using append you can add only one element, but using extend you can add a whole list of elements, right? So whenever you want to add more than one elements, you need to use the extend button, right? So it is equivalent like you are doing the concatenation, right? So extend is used to increase the size of list even more than one, right? Basically extending a list by a new list, right? So let's say this is a earlier list we had, and this is a new list which we are adding to it, right? Then we have the index. Sometime I want to know at which position particular element is existing, right? So I might be interested that apple is at which position in my list, right? I might have very huge list and I don't remember which element at which position, and I'm interested to know at which position element apple is, right? So how I will write is fruit here. So because list name is fruit, all the places in place of list, fruit will come. Dot index, right? Because I want to search for it index, and then the name of the element which I want to search. So let's say in this case apple, then I will write here apple. Okay. Then we have a remove function, right? So remove function do what basically? Remove function will remove the particular element, right? So if I want to remove, delete, let's say grapes, let's say in my fruit shop grapes got finished, and now I want to remove it from the list of my available fruits, let's say. So I can use list dot remove element, right? And list in place of list, again we will write fruit dot remove, and here we will write the element name. Let's say here this is grapes, right? Sometime we are doing an operation, right, and where it is needed that we have elements in a sorted way, right? So it might be, let's say I created a student's name list. Okay, sort do what? As its name suggests, it is used to sort all the elements we have into our list, right? So I might want them sort in the order of alphabetical way, right? Where apple would come first, then grapes will come next, and at the end mango will come, right? And then reverse, sometime I want to completely reverse my list, right? So that grapes become first element, apple become second only, and mango become last element. Okay, so let's do all these operations before we go ahead with little bit practical. Okay, so let's see all of these operations one by one, and also I will tell you that you doesn't need to worry about remembering a lot of function actually, right? So this is a Jupyter IDE, right? So initially I started this IDE and then show you these two things, right? So good thing about Jupyter IDE is that it runs in a browser, right? So I even you can run it using your server, right? Your in reality the execution might be happening in the server, but you will be having such a way IDE into your own system using which you will be interacting to the server and sending your code to be executed, right? Currently if I have downloaded here, you can see actually installed here Jupyter notebook. Server is basically executing here itself in my local system only, right? But sometime it might be that your server is somewhere else. Okay, so let's start with the very basic thing, right? So one of the thing you can see here, like if any one of you who is completely new to programming, that you can think that I am storing here in some memory value 10, and I am pointing to this memory by variable a, right? So this is a value 10 into this memory which is being pointed by a, right? Similarly, we can have some other value here like string, right? And this is we are pointing by the b, right? So this is what we are. So whenever I want to access this a, I write whenever I want to access this 10 value, I write here a. So there is a function print which is being used to print the value of a, right? So you can see here 10. If I'm writing print a, it is printing the value of a, that is 10, right? Similarly here we can look for this string, right? So if I write here print b, right, I am pointing to this particular variable, then it is going to print that string here, right? So this is very basic stuff. I think if you are completely new, then you might need to know this thing. Okay, so about list. So one thing we can say here, let me tell you few more thing here. Once again, let me write here a few things about it so that you can remember. So list are ordered sequences, right? So why do we call them as ordered sequences actually? Because using their position means in whichever position I'm sending the element, I'm storing the element using same position, I can get them back, right? But there are some sequences in which you don't have right, you do not have any rights to store the elements at particular position, and so you can't access those elements using their positions. Those are different kind of sequence, you will see them, but in the list these are ordered sequences, right? And very good thing about them is actually this is about nearly all the sequences that you can store variety of object types, right? Can be stored. It's not necessary like in C language or C++ where you should have all the elements of the same data type, right? It is not like you can have any variety. So for example, what? So let me show you, let me create here our first list. Let's say this is a list one, right? And I'm creating 1 2 3. So I can create this way my list and we can print that list one, right? So it means what? Basically now I am storing 3 elements, right? So you can think list one is a container where you can store multiple values or multiple elements, right? So if I print this list one, then you can see it is showing me all the values there, right? And we can access them with their indexes. But let's talk about I can store variety of objects, right? So for example, one value could be like 1 2 3, then we can have some more values into it, like we might have, let's say, name Gaurav, right? We can have some float values like 4.5, right? So let me give another name, even we can keep it same, no issue. We do print list 2, right? And here we can see 1 2 3 got of 4.5, right? So you can see I can store different types of data types, right? Elements of different data types in a same list, right? So heterogeneous elements can be stored. So Mallikarjun is saying in list squared bracket is must, or we can execute without that. It is must actually. This bracket is only telling that this is list actually, right? This name is not telling. I might give any name here, right? This is just a pointing name, right? Which is pointing to this list, right? I can have another name. I can write fruit, anything, right? Is equal to, and then this thing. So the writing these square brackets are very necessary, because this is what telling to the computer that this is a list, right? Otherwise there is we will not be able to tell that this is a list or some other sequence, right? We have multiple different kind of sequences are there, and this is what these brackets are making differences. Okay, so let me just remove this thing. We have created the list, right? Then we have the indexing concept. We are talking about indexing and slicing. So let's see what is indexing. So indexing means I can access these elements by their position, right? So what is the position this element is having is the 0. So if I want to access the element at the position 0 within the square brackets, again I will write the name of the list in which element is stored. Then within the square bracket I will tell what is their position. That is here like 0. So I write it 0, and if I execute it here, then you can see it is returning me result 0, right? So there is a good thing about this Jupyter ID that sometime, actually many time, it gives result as such, even writing without print statement. There is a reason behind it, in which case it takes, but we will not go into that detail currently. Let's keep it to the basic stuff. Okay, so here you can see I can print the element at the 0th position. Similarly, I can print any other element by their position. Let's say I want to get this element which is correct. So at which position it is? 0 1 2 3. So at the position 3 this element is stored. So if I write list 2 3, then you can see I can access the element at the 3rd position, right? So this is what we say as a indexing, right? Okay, so let me tell you that you might be interested sometime, right? You might say that I have a big list actually, right? Let's say I have 20 elements or 40 elements and so on, right? So let me, before saying this statement, actually let's talk about some of the operation we saw, so that we can use the same to create bigger list, right? So like concatenation, right? Sometime I want to concatenate two lists, right? So here I have one list, list 1, another list, list 2. So let's concatenate these two and store the output into list 3. So for concatenation, we have very easy way. We write list 1 plus list 2. So this concatenate, this addition symbol, whenever there is a list, it works like a concatenating, right? So if I write it and then print the value of list 3, then you guys can see it has concatenated both lists, right? The first list was 1 2 3, and next list was 1 2 3 core of 4.5, right? Both of them has been concatenated together. Let's talk about the repetition of the list. So repetition, we write, let's say if I write list 1 into, let's say 3, right? So what you will see, list 1 has been repeated 3 times, 1 2 3 1 2 3 1 2 3, right? So whenever I want to do repetition, I can write it like list 1 into 3, right? So whether I write it here directly, or I can do one more thing, I can write here like list 4 is equal to that value, that is list 1 into 3, and then I print here list 4, right? So both would be doing the same thing exactly. So this is my repetition operation. Okay, so we did indexing. So let's do one thing. Let me take list 3 and list 4 and concatenate them together and make a list 5, right? So I'm going to make list 5 by concatenating list 3 and list 4 together, right? And if I print list 5, then you will see such a big list has been created to us. I'm telling you there are some more things on the indexing, right? So like this is at the position 0, this is at the position 1, this is at the position 2, and so on, right? So if I write here, which I already showed you, let's say if I want to know what is the value of this particular, what is the value at this position. So what I have to do, I need to go from the starting, right? But sometime what if I want to start it from the back? So we can do the indexing from the back as well. When we do it from the starting, it is starting from the 0 position, then this will have first position, this will have second position. And if we start from the back, it will be in negative way. So the first element from the back will have -1, next element will have -2, next element will have -3, and so on, right? So we can use any way, we can start from the back side as well, indexing. So let's say if I write print list 5 -1, right? So what you will see, it will give me the last element, right? Because this is at the position -1, right? So we can do the indexing from the back as well. Okay, the next concept comes of the slicing, right? So let's see the concept of the slicing. So for slicing, let's using slice, what we do basically, we tell from which element position to which we want to. Let's say if I'm interested from here till here, these, right? So I will be telling, okay, start from the index 1, and this is 2, 3, 4, 5, 6. This is having index 6. So I need to write 7, because always we need to write one more than that, right? So how we will be accessing all these thing element, I write list 5, and I will say from which position it should start, 1, right, in the square bracket again. So I want it to start from 1 until where I want to go. So I will write here colon, and I will say it should go 1 less than 7, right? So if I do this thing, if I print it, so you will see here we are able to access that particular sublist, right? So this is slicing. Sometime what might happen is that I might want first this element, after this I want this element, means I want to skip one consecutive element, right? And then this element, and then this element. So you can think that after this, after this. So every second element, right? So what I can write here is, for telling every second element, I will write here this 2. And if I want to go, so it will go till 7, which is here including Gaurav, right? So it will give me 2, 1, 3. But let's say if I want to go till here, right? So this is having index, let's say 6, so it is 7, it is 8, it is 9. So we write here basically in place of 7, we let's go till 10, right? So here if we do this thing, then what you can see here, 2, 1, 3, after that 4.5, after that 2, right? Because here I have said till 10, right? We can tell it till last as well, right? Even we can skip more number of elements, we just need to mention it here, right? So this is a slicing, basically taking the sub part of the element whose indexes have some pattern, right? Maybe like every second, every third, or every consecutive element. In any ways you guys can do this thing. Okay, so I hope so it is clear to all of you guys, right? So as we say, so let me just take simple list again. Let me print list 1 again for you guys. And now what I'm going to do here is I'm going to append an element to it. So let's say if I write list 1 dot append here, and let's give it something, appended element, let's say appended element, right? So if I show you now list 1, right, so you can see it has added this element more to it, right? So this is what append function do. Similarly, we have if we want to delete the element which is at the last position, right? So then we have as pop function, right? So pop function, I do not, even though we can tell about that which position, right? So pop function, there are a lot of things actually. Let's say that there are few more things about Jupyter IDE. Let me tell you, if I want to see which are the available functions, right? Even though we are seeing very less number of functions, then let's say if I want to see all the function, I press tab here, and it will give me the all the functions here, right? So this is the whole list. Let's say I'm interested in pop function, I write here pop, and I write here bracket, right? Let's say if I do not know what is the signature, what values need to be passed, right? So I can do what, I write here, I press shift tab, and what you are seeing here is by default it is taking index is equal to -1. So it always pop the element at the position -1, but it doesn't mean I can't give any other position. So if I give any other position, it will be popping that element. So let me show you this thing. Okay, with this only list we will do this thing. So let me do this list1 dot pop. You can see it is returning this element, appended element. And if I show now list1 to you guys, then you can see that element has been removed from my list, right? So pop basically by default remove the element from last position, and if I want to remove the element from other position, I can mention it. Let's say if I want to, now this is a list1 I have, right? And let's say I want to remove this particular element. So what is the position it has is 0. So if I write here 0, you can see it return us the result that what it is popping, that is value 1. And if we look now list1, then you can see only 2 elements are left, 2 3, right? So this way we can tell whichever element we want to pop. Okay, so let's create a list. Actually, let's say list1 itself. Let me create a new one, and let me write here some different element. A, X, let's write here E, then let's write here B, right? And this is the list we have, actually we have created of the characters. Now if I want to sort it out, so how I can do it, I will use simple function list1 dot sort, right? So when I call sort function, automatically it sort the list. So if I do here now print list1, then we can see A B E X, right? So here it is showing here A B E X, right? Initially while the element was A X E B, right? So in whichever order I write, the moment I write here sort, it would be sorting my elements. Okay, and there are a few more functions. We have lots of functions, so let's do here like list1 dot remove, right? And if I write let's say B, then what we will see here list1. Now if I see the list1, sorry, list1, if I see now, you can see B element has been removed, right? That has been removed from it. Okay, so we discussed about remove. Similarly, we have extend function, right? List1 dot extend, right? So let's say I have list1 here and I have already list2, right? So if I write list1 dot extend list2, then if I see list1, then what you will see after list1, it has added the element 1 2 3 GOR of 4.5, right? That becomes my list1, right? Let's see what it will do if I do append, right? So let's say if I append here list, then you see what it is going to do. So if I print the output now, then you will see it has been appended as another list inside it, right? So we say it as a second dimension within the list here we have, right? So it is appended as this would be treated for outer list would be treated like a one element, but that is a list itself. So we call it as a list within the list. Let's talk about insert function as well here. So I write list1 dot insert, right? So at particular, so once again, let's say if I want to see the signature here, you see here first thing is need to be index and then the element, right? So let's say within this list1, I want to add this let's say this position, right, which is index. In X should be shifted right, and in place of X, let's say I should say inserted value should come. So what is the index is 2, right? And within this we want to write inserted value. If I do this thing, if I show you list1, then actually now it cannot come into the straight line, it is getting bigger. So it is showing here inserted value at the second position, right? So don't think that this and this thing is, because this is coming now in big in elongated way in a vertical way, because it cannot be printed more into a horizontal way. So it start giving us output in a vertical way. Okay, we can use the index function. So let's say in list1, I want to know what is the position of X, let's say, right? So we say index, and here I want to know what is the position of X. I write it, so it is printing back the third is the position of X, right? If I write here, let's say this one is coming here, if I write this one, then it is finding as such. This is a string value, actually I am passing it, but there it is a number, right? So if I write list1 dot index 1, so I am saying find the index of the number 1, it is giving me as a fourth position, right? So this way we can access their positions. Okay, before one more thing I want to show you before we go ahead. And that is basically, let's say if this is my list one, right? Okay, let's say in this position I want to replace this value by some other value, right? So how I can do it? I can do it, I write list one, and at which position I want to replace the value, at the second position. So I write here 2, right? So if I just see what value is this, is inserted value, right? But if I want to replace this value, so I will write is equal to, then I can write, let's say, replaced value, right? If I write it like this, show you what is list one, then you can see inserted value has been replaced by this new value which we are passing here, that is the replaced value. Okay, so this way we can make the changes within the list, right? So there are a lot of things about the list, but let's keep it to the basics. Okay, so let's go and talk about the tuples. So when we talk about the tuples, so tuple is similarly as we have the list, but there is only a minor difference. There is no difference as such in between of tuple and list. The difference is that it is immutable. Immutable means once you fix your tuple, then it cannot be changed, right? Whatever element you assign to it, then you cannot change. You cannot delete the element, you cannot add new element, you cannot change the older elements, right? But in other operations you can do with the tuples. Okay, the like indexing, slicing, all those things you can do, right? You can create a new tuple, right, by concatenating the things, by doing repetitions, right? But you cannot make the changes within the tuple. And how do we create the tuples? So it is completely like list, other than this, the simple difference is that in place of square bracket we write C brackets, right? So these are the brackets which we are going to use to tell that this is a tuple, right? So here we are making a tuple symbol. We are writing here mango is the first element, comma, apple, comma, grapes, right? Okay, so this is the little difference we have here, and it makes big difference actually in reality when it comes to processing. So again, the way we have index function into list, similarly we have index function into tuples. The way we have slicing function into list, similarly we have slicing into tuple. The way we have concatenation there, here also. The way we have repetition there, here as well. Similarly, we have one more function, that is count. Count function do what? Basically it tells how many time a particular element is coming. Okay, so okay, before going to string, let's do few experiments, right? Let me show you the tuple. Okay, so let's go directly to here, right? So this is list one actually. So if I write list one dot count, right? So if I want to count, let's say particular element, let's say 1, how many time it is coming, right? So in this it is coming only once, so it is showing once only, right? But if we see any of the other here earlier, any list in which we were repeating the elements, so like list 5 we had actually. So if we see list 5, how many times it is coming, right? So let me show you list 5, right? And if I write here list, let me just copy paste this thing, right? Within list 5, how many times 1 is coming, if we check, then it is telling us 5 times it is coming, right? So 1 2 3 4 5, right? So count function can be used this purpose, and this is available also for tuples. So now let's create the tuple and see what are the differences, right? So as I told you, small differences there. One thing is how we are telling to our system is by using these C brackets, right? Our parentheses we can say, and within these parentheses we will write our element like 1 2 3 4 5, let's say, right? So if I show here now tuple 1 is this, right? Even we can check the type of that, which particular element it is, right? Which particular type it is, sequence it is. So if I write type tuple 1, so you can see here it is saying it is tuple. And if I say type of any list, let's say which I created was list 5, and it is being shown as a list, right? So indexing and all those things we can do as we were doing on the list, right? So I can easily get the element which is at the position 0, right, which is currently in this here is 1 only into this tuple, right? Similarly we might want to do, let's say, from second till fourth position we want to take the element. So we can use the slicing here as well, right? So slicing and these things are working. Let's say, can't I append the element? So if I see here tuple one dot the list, only two functions are available, count and index, right? Count for counting the elements, index for finding the index of a particular element, right? Append and all those functions are not available to us. I can't do append some value 4, right? So if I do this thing, you can see here it is saying tuple has no attribute like append, right? We can't change value here, right? Similarly, as earlier I was changing the value in my tuple upside, right? So like I was writing tuple 1 0 is equal to 45, let's say. If I try to do this thing, then you can see here it is saying it doesn't support item assignment, right? Once the tuple has been created, then you cannot assign new element to some position within the tuple, right? So this is the thing. This is the difference between the tuple and list. That list is mutable but tuple is immutable. So what is the benefit of that? List benefit, we are all understanding. If I compare list and tuple, then we can say yes, list has a lot of benefits. It is providing us lots of function. We already saw the functions it is providing. We can change the value also and all those stuff, right? Sort, reverse, and all kind of stuff. But tuples do not provide all these facility because it cannot change the value. But because of its immutability, because it is fixed the element we have, right? Then it is then we can say that it is faster compared to list. Let's say if you just want to read the data, right, and you do not want to do any operation which need to edit the things, right? So we cannot, so which is need to which particular sequence we should use, list or tuple? Obviously we should choose tuple, right? Because tuple provide faster accessing of the elements. So using these ways we can definitely do the execution. So is it possible if I have the elements like, let's say tuple 2 is equal to having some element 1 2 3 4, and then I have some list, let's say 5 6 7, and then I have element 10, right? So yes, you can see here tuple 2 has been created. This is a list and this is the whole thing is tuple, right? And now the whole thing comes within this list. So this list is at a particular position within this my tuple, right? So I cannot change any of these values from the tuple point of view. Neither I can change this thing nor this, neither this nor this nor this, right? Same with this thing, right? This is element from the tuple point of view. Using tuple I can't change the value, but using this list operation I can make changes within this list, right? I cannot add any other new list or any other value in the tuple at this position. This list would always be there, but this list can be edited. So if I try to do tuple, so how I can access this whole list? By its position. So from the back side the position is, this is -1, this is -2, so position is -2 I can write here, right? So I can access this one, right? And now within this list, if I want to access, let's say this in between value, I can access it by using this one, right? And here I can write, let's say, changed value, right? So now if you see tuple 2, if I show here, you can see at this position value has been changed, right? But if I try to make the changes within this tuple, right, and any position, right, so maybe at 0th position, right, some value, then you will see it will generate a error message, right? So because this doesn't allow the item assignment, right? So yes, there are ways you can do the changes in the value, right, using list actually. So you cannot yourself delete, remove this list cannot be changed by some other value within the tuple, but within this list you can make as many changes you want to do because this is a list, right? And similarly you can have tuple within a list as well, right? So like we have list within a tuple, similarly you can have tuple within the list as well. Okay, tuple can be converted to list as well, right? So we have the conversion as well. We can convert a tuple into list or list into tuple, right? So like here, let's say I have this tuple 2, I want to convert into list. Let's say this is I call it as, let's say, converted list. Then I can do it by calling a tuple function, and in this I send tuple, right? So if I look converted list now, then you can see, one second, here I am writing tuple only actually. Tuple function will convert list into tuple or anything which is possible convertible to the tuple, it will do this. But if I want to convert it into list, I need to write here list, right? And you can see here that this thing has been created into the list tuple2, right? So yeah, all these things. So we have the conversions possible. So you can do back and forth conversion as well sometime if you want to keep the things going on. If you so this thing you can do, and for example, let's say you know that very rare you need to make the changes in your sequence, let's say, right? Let's say in a day only once I need to make a changes, otherwise whole day whenever the access is need to be done, it should be given, right? Only read operation happen from your tuple. So what you can do is for that particular value you convert it into list, right? And then within the converted list you make the changes. Let's say at the position 2 you want to have some value, let's say some value, right? And you can see now this is converted list, right, in which changes has been made. Now I can change it back to tuple, and same tuple, let's say tuple2 is equal to, I write here tuple, within this I pass this converted list, right? And now if we see the tuple2, then we can see this tuple got this particular value changed, right? Okay, so let's go to the next sequence, which is strings. Okay, so let's, if we talk about the strings, string is, you already know what is string actually, right? So it is like it is a combination of characters, right? So it is again sequence because particular combination make a particular string, right? So like mango, apple, grapes, right? Here we are not putting any comma in between. We can say today is a beautiful day is one string, right? Or we can write one character also which would be treated as a string. And you can define your string using single quotes or double quotes in the Python, right? While in other programming languages it is happening in double quotes only, but in the Python you can define a string in a single quotes or in a double quotes. It's completely your choice what you want to use. Okay, and because in Python even a single character is treated like a complete string, right? There is no data type like character in the Python. Okay, so again within this, because this is at the 0th position, this is at the first position, this is at the second position, this is at the third position, and so on, right? So we can do all the operation on it as well, like whichever operations can be done with the sequences, right? So like slicing, right? So as we were doing earlier slicing, similarly here we can do updating. Again, this is actually directly updation is not possible within it, right? Again, this is a immutable, like we have tuple which is immutable. Similarly, this is also immutable. It means we cannot directly make the changes, but there are ways we can make the changes. I will show you just in a minute. Then concatenation, as we were doing with other sequence, similarly we can do same with the repetition. Next is membership test, right? We didn't check it with other till now actually programmatically, but it can tell us whether a particular element is available into my sequence or not, right? And I can do it with any of the sequence actually, right? And reverse, basically that is being used to reverse my whole string, right? So actually this is given in a wrong way. I will show you how to do this thing. Okay, so let's go quickly and let's talk about the string. Okay, so first of all, let me show you even within that tuple, right? So let's say 4 element is available in tuple2, right? So I want to check whether 4 is available or not, right? So if I write 4 is available, it is returning true because 4 is here, right? But let's say if I say 41 is in this tuple or not, then it is writing it false, right? That element is not existing here. Okay, so now let's discuss about our string, right? So string we can define some way. Let's say string 1 is equal to, let's say this is beautiful day, right? String 2, let's say I can define some more string 2, I write, and tomorrow even will be more beautiful day, right? And so this way we get these two string, right? We can play around these string. So again I can access any of the element there, like with their indexes, like t is at the 0th index. So if I write string 1 0, so it is t. Similarly I can write here -1 for accessing, that would be -1 here, right? Similarly we can do the slicing, right? So if I do slicing, let's say from the 0th position I want to start, and I want to have 0 1 2 3, right? Basically I want this keyword completely. So we go till 4 and we can access this keyword, right? So this is our slicing only, right? So we are getting a slice of this particular sequence. And as I told you, this is immutable again. We cannot make changes here within it, right? So if I write string 1, 0 position in place of t, let me write, let's say I want to have p, then it will give error, right? That it doesn't support item assignment, right? So again, changing value is not available directly, but we can do the changes. Let's say in place of t, I want p. So how I can do it? I can use the concatenation way, right? So let's say I write here string 3 is equal to, first thing I want is the p, and the rest thing I want from this string 1, everything from the first value, right? So I write string 1, right, and I write here from position 1, right? 0th position element we want to miss. From position 1 I want to have everything else, right? So if I want to have everything else, I do not need to write here the last value. So we can write even count number of characters, and we can write it here as well, or we can use an inbuilt function which is a len as well, len, right? Len string 1. So it will tell us how many elements are there into this, right? So if I show you this string 3 to you now, so what you can see is in place of t, p has been added, right? So using this way, using the concatenation and slicing together, we can make the changes within a string, right? Or I can store back in the string 1 as well, but directly within this string I cannot do any assignment or changes, right? Because this is immutable. Okay, so I hope so it is clear to all of you guys, right? And there would be, like, you can do other operations as well, like let's do the string 1 plus string 2, that is for our concatenation if we do. So you can see this is beautiful day, and tomorrow even will be more beautiful day, right? So this way we can do the concatenation simply. We can even do the repetition, which we already saw with other tabs. So you can see this is beautiful day, this is beautiful day, this is beautiful day, right? 3 times it has been concatenated. Okay, so this way we can find out the index of a particular character also, right? So if, let's say, if I am interested dot index, let's say I'm interested in index of t, right, capital T. So it is saying at the 0th position this element is lying within this string, right? String 1, t is at the 0th position. Okay, so this way we can play around. Okay, so let's go membership also, we have not seen. Okay, so let me show you one more thing. Let's, even though we have the reverse way, but using a slicing way, we can use, we can reverse a string as well, right? Or any, actually any list, right? So one way is like, so what does this -1 is telling, right? I hope you remember this slicing, that here I tell with what value it start, right? So if I do not give any value, like if I give like this, so what it will give it, it will start from the 0 and it will go till the length of my string, right? So this is, right, by default value, even if I do not write it, right? So here, even if I'm not writing, then you can see this way it will go. Okay, and if so, default value it is taking 0 for it is this, and there is a one more default value it is taking, that is a jump of one character, right? And if I write here that first two values I want to take default, but the next value if I write 2, then what you can see, there is a jump of two character. From t it is jumping to I, after that it is jumping to space, after that jumping to s, after that b, right? So it is keeping one element, right? So I told you -1 is starting from the back. So if I write here -1, it means start from the back, right? So jump starts in the reverse direction, and here it takes the default value, this become the end default value, and this become the start default value, right? And it goes in the reverse direction in that case. Okay, so let's talk about the set. So we will go quickly around the set, right? So let me just make this thing to your screen. So set is what, like, as we have, if we want to do mathematical operations, which we want to do like a set operations, right? So for that, set is available to us. Okay, so set, like set theory we have, we can take the union, we can take the differences, right? We can take the intersection of the two sets and so on, those operations. All those operations we can do using set. right? But we cannot access the element, right? We cannot access the element separately according on the basis of their positions, right? So it means this is an unordered collection, because they, in which order I am passing, it doesn't matter, right? So it is completely unordered, okay, collection. And that is of unique element, means one element only comes only once. If you are trying to write one element twice, thrice, or four, it will take still only once. It cannot take more than once a single element, right? So that is what you need to make sure, that that if even if you are adding element, if you want those elements which are not repeating, then set is the right data structure to be used, okay. And if we see that all the mathematical operations you can do on it, okay. So let's see what are the so like how do we define this set. So like list with the square brackets, tuple with the C brackets, and the sets with the curly braces, right? So when I write the elements, like this is element 1 comma element 2 comma element 3, right? This become a set, okay. And it might happen that if I write in this order, if I print it, it might not be in the same order, right? And let's see this thing actually, but we cannot do slicing on this actually. We do not have this is, let me just do this thing. So let's see some of the operations we can do on the sets. So let's create a one set one, right? So let's say set one is equal to, in the curly braces we can write the elements, let's say 1 comma 2 comma 3 comma 4, right? So if I write set one, okay, let me do one thing here. Let me write here 4 comma 1 comma 2 comma 2, right? I execute this statement, and if I print set one, then what you can see, that each element is coming only once, right? So it doesn't matter that how many times you are writing any element, it will only add each element once, first thing, right? Because it makes sure that each element is unique in the set. Another thing is, let's say if I remove 2 from here, right, and if I print here set 1, right, you can see even though first element I am passing here as a 2, but still it is coming 1, right? So in whichever order you give it, it doesn't take care, it doesn't take in that particular order, right? It has its own way to taking care of the order, and it will always store the element into that same order, right? And how we can add the element, we can add the element by writing set1 dot add, and here I can tell which element I want to add. Let's say 7 I want to write, so here I write set1 dot add, and in the bracket I pass the element value. Then if I look here set1, then you can see that element has been added, okay. So this way we can add, and again if I try to add this element value, then it will not take, right? So if I try to have set1 dot add, if I write here 4, then you are going to see still it is coming only once, right? So let's create one more set. Let's say this is set 2, and here within this set 2 we are writing, let's say 2 comma 3 comma 8 comma 10, let's say 81 comma 10, right? So we have two sets now, set 1 and set 2, right? So we can do the operations which we can do on any set, right? So like you guys, if you guys have studied discrete mathematics during your college time, or if you are already in the college time, then you can see you can use this thing. So here we have many different functions which are available to us, right? Let's say if I want to use union, I write here set1 dot union, and I write set2, right? And if I execute it, then you can see this is the output of union. So what you can see here, this is my set1, this is my set2, and this is my union. So what does union give us as an output of a result, is that each element comes only once, right? So you can see even though here like 2 was here as well, still here it is. So whether the element is here or here, within set 1 or set 2, it would be coming for sure uh, once in the final output, right? Similarly we have the intersection, right? So if we write intersection here, we write set 2, right? So if I do this thing, then you can see it is finding the common elements, right? So common elements here we have is 2 and 3, right? Within the set 1, 2, 3 available, within the set 2 also 2, 3 available. So intersection is returning us that element, right? Next sequence which we have is one of the very important sequence, that is dictionaries, and it is used a lot actually, right? You can solve a lot of problems. So dictionary is what actually? In dictionary, first of all, it is an unordered collection. It means again you cannot access the element in which order you are giving the element. And what do you give here is key value pair. So what does it mean is here you are giving your own way to access, right? So you are giving your own indexes. That is, key is going to be the index of this value, right? So there in the list, what was happening? It was happening like 1, 2, 3 I was writing. So 1 always become at the 0th position, 2 become always at the first position, 3 become always at the second position, or we can say these were their indexes, right? While in the dictionary we tell what is their position or their indexes, right? And it's not necessary to be a number, it could be even your string, right? So here you can see that we are defining a dictionary. And how do we define it? Again with the curly braces which we were using for set, but there here we get the one difference, that we get pair here, right? For every value before a comma there is a pair. So here we are writing that 1, so 1 is going to be the index, and at this index which value I want to store is value. So using this index I can access this element. Similarly, another index I am defining here, you can say key, which is name is key only, and I'm storing at this particular index my value 2, right? So when I want to access d1 I write here, then it will be returning me this value. When I write for this, it would be returning me this value, right? And if we try to access something which is not existing, then it will give us error. So let's see this thing. So we are going to create a dictionary quickly. Okay, so let's create a dictionary quickly, right? So let's say this is my fruit dictionary, right? So let's say I want to create a dictionary for the prices of fruit, right? So I write here, let's say apple, and its prices are, let's say 34, right? And then second, so this is the first key and first value. Second, let's say I want to say banana, and its price is, let's say 90, right? Let's say third we can have, let's say orange, and we have its prices, let's say 70, right? So this is a dictionary we have created here, right? This is the index and this is the value, right? So now if I want to know what is the prices of apple, right? This is a good thing that this way I can access it. I write fruit dict in the square bracket as we do any indexing. Here we pass which I want, what I want to look in, which value, which is stored at the apple index. So at the apple index we have stored to store the 34 values, so it is showing that. Similarly, we can look for the prices. So you can see here now, using this dictionary itself, you can make very easily your system of for finding the prices in your shopping mall, right? And it is showing here 90, right? So pretty easy way you can see here. Okay, so these we call as a key. In reality we call key, but to make it simple I have told them indexes as well. Okay, and it's not necessary that you should always have like this way. Even I can have some random, and we can have some number as well. At 89 we can say value is stored, right? Let's say some value is stored, right? So if we do this thing, these things will be as such. And if I write here fruit dict, and within this if I write 89, access it, then you can see whatever value is stored there, it would be shown here. And not only this thing, I can store even list, tuple or set, anything I can store in value column, right? Okay, so I hope so it is clear to you guys. Let's say if I want to see all the keys, right? I can get all the keys. So for that we have a function, all the keys or all the values we can see. So if I use dot keys function, it will return all the keys, right? So apple, banana, orange, 89, right? Similarly we can use predict dot values, and if we see it, it will be sending us all the values, right? This way we can access the just a key or just the value. Okay, right? And definitely we can do the member testing as well, right? So let me just go to it. We can do even whether a particular key is existing or not. How do we do it? So like this is, I want to see whether, let's say, 20 key is existing or not into it. So I write 20 into dict dot keys, it is saying false, right? But if I write here, let's say 89, then you can see it is true because 89 is existing, right? So this is what we call as a member testing. Okay, and we can delete any key value pair by using the delete keyword. Okay, so if I want to delete, let's say, this 89 key value pair, I write del, I write here few dict, and then I write here 89, right? So it is deleted. If I now show you what is my fruit dict, you can see 89, it is not existing anymore. Okay, okay guys, all the best for your life ahead, for the careers. Bye bye, take care, enjoy your life to the fullest.